Collision theory. We learned in the previous video for the activation potential energy that for a reaction to proceed, there needs to be a correct molecular geometry orientation as well as a sufficient amount of energy to hit the activated complex barrier. Well, during this process, what factors affect the rates of reaction? Well, the first one is reactivity. If we have more bonds or stronger bonds involved, so as you can see here, we have carbon and oxygen and hydrogen. What are they forming? As you can see, we see the CO2 being formed and the H2O being formed. As opposed to this one here, none of it is really being formed from the reactants of the product. So of course here it's going to have stronger bonds and more bonds involved. So of course this is going to be a slower rate. Next we have the ionization energy. I'm going to write over here, that's number 2. If there is a high ionization energy and a low electron affinity, this is going to be a slow rate of reaction. Why? Look at this example here with neon. Okay, we've drawn it out over here. It's going to require a lot of energy to remove an electron from this very last shell, because this neon is already very happy, it's very stable, so you have to absorb or give it a lot of energy for it to take away an electron. It does not want to do that. How about the electron affinity? Will this neon pay lots of energy in order to take an electron? No, it definitely does not want to do that. It's not excited to do that, but it's already quite stable, hence why a low electron affinity. So this here will be a very slow rate. It's going to be the opposite vice versa. If we have a low ionization energy and high electron affinity, it's going to be a fast rate. Next we have temperature. Okay, if there's an increase in temperature, this should be quite obvious if this is going to increase the rate of reaction. Due to more kinetic energy of all particles is going to increase the amount of collisions, effective or ineffective. So therefore, if there is an increase of effective collisions, this is going to help increase the reaction to proceed. Next we have concentration. It's the same deal. If we increase concentration, we're also going to increase the rate due to, again, increase the amount of kinetic energy because we have more particles that are being involved in the same amount of volume to hit each other. So it's going to increase collision, and it's going to also increase the effective collisions too. Okay, so it's going to proceed. Next we have the surface area. If there's high surface area, this is also going to increase a faster rate of reaction due to more particles being exposed to collide in the same amount of time. So for example, wood shavings and a wood block, of course during the same amount of time of ignition, right, of the fire, the wood shavings, more of those particles are going to be hit and it's going to ignite at the same time as opposed to the wood block, because these are all condensed and compact. And another example could be like a sugar cube. A sugar cube is going to proceed a lot slower to dissolve as opposed to if they were just powdered and then just thrown into the water. Next we have a catalyst. If you add a catalyst, you're going to increase the rate because you're going to decrease the activation energy. Again, see the previous video for the potential and activation energy for illustration of this. Due to more effective collisions, it also improves molecular geometry. Let's look at this question over here. Well, of course, as we can see here, temperature. If you were to decrease temperature, this is going to decrease the amount of overall collisions. So of course, it's going to slow down the reaction of rusting, as well as if you were to decrease the surface area, because if you were to cover it up, a particular area, if you were to cover it up, there's going to be less rusting that occurs because not all of it is going to be reacting with the oxygen. Now look at this question on your own. Please try this yourself. Please pause the video and I'll give you the answers shortly. This is the answer.